script, just another script for now. And we said, let us load our library. The library that we're using today is tidyverse. Then we load that. You can run it. Or click control, then enter. Now, as you can see here, there is this word tidy. So what you're working with are tidy data principles. And I would like to take you to a section in a book that I shared with you that talks about tidy data. And here it is. This is, I think, I don't know, the 12th chapter or so. So it talks about, first there is a quote by Leo Tolstoy that says, happy families are all alike. If a family is happy, the happiness is the same. But every unhappy family is unhappy in their own way. Okay. And also when it comes to data sets, we say that tidy data sets are all alike. They are similar tidy data sets. But every messy data is messy. So, someone please mute your video. I would mute your. Let me try to mute these people. Okay. Now, when you talk about tidy data, let me show you how tidy data looks like. So, there are three interrelated rules which make a data set tidy. And here they are. Each variable must have its own column. For example, if you can see here, there is a variable called country. So that is a variable, has its own column, year, cases, population. So every variable has its own column. So every column is a variable. And each observation must have its own row. So from this row, from the left to the right, these are observations. This is an observation of one row, of speaking of one item. If it is maybe talking about maybe this Afghanistan, we're talking just this row contains details regarding Afghanistan. And then number three, each value must have its own cell. So each value must have its own cell. So there should not be data that is not in this format. So this, I'll share with you this book and then you'll understand more what we mean by tidy data principles. That each variable must have its own column, each observation must have its own row. Now let's go to that. Now let's go to the Tidy Tuesday website that I showed you that we can get our data for analysis. So this week's data, so last week's data was on CRAN. Today, this week's data was on baby names. Anyone with babies, you can get your baby name from here, or maybe you can see whether your name is in this data set. So we just copy this data set, baby names, copy that. Let's go back to our Rstudio, just paste it there and then run it. So you can see it is downloading. I think it has done downloading, and this is our data set. We have it now here. Baby names. So when you click here, we can see how it looks like. So you have the year. So this is from 1880s to I think 2017. The gender of the baby that is born, the name of that baby, how many babies were born in that year named Mary, and what is the proportion in relation to the whole population. So babies that were born, this Mary, so there were 7,065 babies born whose name given was Mary, and Anna was 2,604. So that this is what this data is all about. So, so this is tidy data, as you can see. So every column, it's a variable. So this only contains year. So we don't have anything else here apart from here. Sex here. Here we don't have anything apart from the gender of the child. And in here, this variable name, this column contains only the names, not anything else, not year, not gender, not anything, just the name. And n, this n, the number, this contains the number of just the count, how many of them. This n only contains n, and the proportion. So these are something that is the division of this divided by the total number of babies born that year, and give us around. So the babies that our named area about, see, 7% or so. Okay, so that is the data now. When it comes to tidyverse, there is a package called dplyr package. This dplyr package is within the tidyverse package. Now, this dplyr package, okay, you've seen I've added a hashtag here. This is to show that this is not a code that needs to be run. This is just a comment. So this is done to show that this is a comment. Therefore, so we have a package called dplyr, and it is within the tidyverse package, so we don't need to run it. And this dplyr package has functions, have different functions that I want us to go through today. And one of the functions is select. And it goes like that, select. So what this function select does, if you come to a data here, it helps you, if you have a data set with so many variables, you might have a data set with around 100 variables here, and you want maybe to work with only a few variables. So that's why you select the variables that you want. And before we go further, there is something else I want to talk to you about. Let me put this. In R, there is a function called a pipe operator. And let me show you how it looks like. Sorry. A pipe operator looks like that. This is a pipe operator. Sorry, it should not be here. This is a pipe operator. This pipe operator, what it means, if you want to put the pipe operator, just hold Shift, Control, and then M. Shift, Control, M. Shift, Control, and then M. It gives you that pipe operator. And what this pipe operator means, it just says and then. Just means and then. Just get that. It means just means and then. Just that. It means and then. And I'll explain how that works. So we take whatever is on the right, on the left side, and apply to what will happen in there on the right side. And this is what we do. So number one, we take our baby names, our data set is baby names. So you can even copy that. So we are saying we have that baby names, and then we put that pipe operator that says and then baby names. So we have selected our data set baby names, and then I want us to select and then. So we're taking baby names and then select. So we can select any of these variables using the name. So we may select year, let's say year. So what happens here, as you can see down here, you have selected the year variable, the column that has the variable year. That was we just selected. And you can put a comma and then select maybe something else. Maybe you want year and the proportion. So then just prop. See, so you have selected year and proportion. And then this you can make it, you can name it an object. You can call it maybe year, let's say year prop. And then you assign it to using this this symbol just assigns it, just like saying is equals to the year prop. And you can, if you run that, you can see the year population comes here, that data set. Let's click there. So we have our year population data, data that contains the year and the population only. So we have selected those two. Something else we can do.
Excuse me.
Yes.
Mungai.
Yes.
Does it mean if you like if you run it without the gets function year prop, won't it give the proportions?
So I didn't get your question.
No, like if you do not assign it.
Okay, if like I don't assign anything.
Yes.
So for example, so that means I've not selected anything. And if I try to run that.
No, what I mean.
Yes.
You do not assign it year prop.
Oh,
you just run baby names and then select year, comma, then proportion.
And then?
Then prop, then proportion.
instead of the way that it looks here.
Yeah, instead of you assigning year prop. Won't it run?
I don't get it. So maybe what you're
Dan,
doing. Yes.
I get your question. It will still run. The year prop is just a way of you assigning any name that you want to your data set. It can be year prop.
Oh, you're talking about this name here.
Yeah, he is asking if you don't assign any name, like maybe even for this year prop, you could just say maybe baby prop. It doesn't matter.
I can call it maybe
or
DF.
DF. Yeah.
I can call it
It
DF.
will still run even if you have baby names.
Yes.
And then you call it. It will still run.
Exactly. Said, are we together? And we have a DF now here.
Yeah, sure.
Yes. So you don't have to write the name. The name here should just write it so that you could understand what you are talking about. You are just choosing the year and the prop. But this is just a name. It doesn't have any bearing on what happens on this side. So we have just assigned that. That's what it does. So something else we can do, let's just maybe deselect something. We want to deselect. So we take baby names. And then select. Now we want to deselect something in our data set. So we have baby names here. So let's say we want to deselect maybe this N. Maybe you don't want the N. You just have to write a minus sign, then that N. Then when you run that, come here to deselect. You'll find that N is not here. We have removed it. We have deselected. So deselect only helps you to select the columns that you want to work with. Maybe you don't want to work with everything. Maybe you want to work with gender. Maybe let's say sex and the name. Maybe that is what you want. So you just say baby names. Baby names. And then select. We just want the sex and the name. So our data set still comes here. So we have selected that the sex and the name. So you are just selecting the variables that you want to work with. Okay. And if you don't want this, we just put a minus sign here, put a minus sign there, a subtraction sign there, and then we have to move that from our baby names. Let's look at that sex name once more. Let's see how it looks like now. So our data set has everything except the sex and the name. So those are the two ways of either selecting the ones you want or removing the ones you don't need. That is the select function. So the select function works with the columns, the variable names only works with the variable names. Now, let's come here. What if now we just want to subset our data of according to the year, or maybe according to any of the rows? Maybe we want all the people named Mary in the years, or data from this year, 1880s or 2017, any year. How do we do that? How can we subset data according to rows? So we want data that has all the columns, but has only rows that are, or maybe you want just the females only. You don't want the males. You want to work with the females. How do we go about that? Now, that's where another function comes that we call filter. So we want to filter our data according to a certain criteria. And that's how it works the same. So you come baby names, and then says, and then filter. So what are we filtering? Let's start with the sex. So we are filtering in sex. We want to filter in sex. So in here, we put 2 is equal sign, just like that. And then whatever we want to select, we put it in quotations. So what you have here in sex is males and females, so F. So let's put a capital F and run that. So our data now has only the females. We don't have the males. We don't have the males at all. And we can do the same way for males. Maybe we want only the males, baby names, filter, then sex, put 2 is equals signs, male. So in that case now, we have only chosen the males, and you can see it here. Just the males. The first one we filtered according to the females. Okay. Let's try with ear. Filter with ear, baby names, and then filter. So it is the ear is equals to 1880. Let's see how that works. So we have only data from 1880. So let's take 2017. So we can see that the data you have here is only for 2017. So you can try 2000. So we have data for 2000. We can now let's try names, baby names, and then filter name. Let's try to filter the people we have here. In this case, we have let's see whether you have someone named Miriam here. This data set. Yes, there are so many Miriams in there. So yeah, so this data set only contains people's children whose names were Miriam. So send that name Miriam there. Let's try something else. You have Said. Let's try that. Baby names. And then let's filter name is equals to Said. Okay. Let's see. So in here, it tells me there are no people named Said, but that is because I've written it, I've given the first letter to be a small letter. Let's put it the correct way. Said. Yes, no people named Said here, all of them. So people named Said, we have somebody else by Bernadette. Let's see how that works. Baby names. And then filter name is equals to Bernadette. I don't know whether that is the correct way, like that. Let's see. Yes. So these are data sets only containing Bernadette's. All right. Now, what if now we want to filter out? We don't want maybe any person who is named Miriam in this group. What do you do about that? So what we just remove the first is equal sign and then put this exclamation mark. So the first one said name is equals to Miriam, and this one is saying name is not equal to Miriam. So we're saying baby names filter name is not equal to Miriam. So we can say not Miriam, maybe something like that. So in this data set, you not find someone named Miriam at all. So what you have learned at that point when it comes to filter, when you say is equals sign, we are selecting, we are filtering according to that person. We are filtering, we want that person. But when we put exclamation mark, then is equals to, we are filtering out, say filtering out, removing anyone named that thing. So according to the rows. So in the first part on select, we were working with the columns. But now when it comes to filtering, we are subsetting our data according to the rows. Okay. What if now we want to filter multiple? Filtering multiple. Several people want to filter several. Maybe want in one data set to have Miriam, Said, and these three, and Bernadette. So what do we do? How do we do that? Let's call it many, just for the sake of. And then we say baby names. So we want to filter name. Now look here, if you put is equals sign, so in R, you'll come so much across this C, just a small c, put into brackets. So this C means everything that is inside there. It is this, the name itself is called, let me see, concatenation. Putting those things in one group, saying these are the things that I want. So in here, we can, let's put Miriam. Sorry. Miriam, comma, Said. We have to put it in quotation marks, Said. And then we have, I can just copy this, copy, paste it here, Bernadette. So let's try to run that. Okay. So that's called many. Here it is. So these are data sets that contain those three names: Miriam, Bernadette, and Said. Yeah, there. So those three names occur only, you can see 117 times, I guess. Not loading, but that's how it is. So we are filtering according to these three names. And in most cases, instead of using is equal sign, because you might put 2 is equal sign when you're selecting and it brings you issues, it's better to use another helper that looks like this. Sorry, so what this means is that we are saying we're taking the baby names and then we want to filter the name. This means that everything that is in here, we are selecting with everything that is in here. This just saying is the same as is equal sign, but in this case we have several rows that you want to subset, and in this case there is this C to concatenate those names, and then we put this instead of is equal sign. I hope this is not confusing at all, but I'm putting this because at some point you might be working on your own, and then you put the is equal sign when you're working with the concatenated names, and then you find that it's bringing you an error. You should use this function. This means everything that is in here. Filter everything that is composed here. And if you want, let's copy that. Let's put it down here. If we want to filter out these names, we don't want these names now. Remember here, we put this exclamation and then an equal sign. Say we don't want the row that has Miriam name in it. In this case, we have several here, and there is in here we cannot put that that exclamation mark to say that we don't want that person. So how do we go about that? That quotation mark is put before this name, before what you're filtering about, the row, the column that you're filtering. So you put the exclamation mark there. So we are filtering out anything that is in here. So let's put here, maybe not many or so, just for lack of a better way of saying. So we are filtering out everybody that is here will not be there. So not many. So if you look in this data, you're not going to find Miriam, Said, and Bernadette at all. They will not be there. You might wonder why we are learning this and doing this. And this is because whenever you want to do any analysis or to visualize your data, you'll have to shape your data, wrangle your data, and put it in a way that you can be able to visualize it or do it for any other purposes you're doing for modeling also, all those things. Maybe you have a column that has several counties and want to work with only maybe 1 or 2 counties. So you have 47 counties in this country. and then you just want to work with counties. So you can filter out, say, the counties that I want is Nairobi and Mombasa, and maybe we want to work with the city. So that's where filtering comes in. And to show you that, let's go to our Tidy Tuesday data sets. Let's see, let's try something else. And I think it was, last year, 2021, some data was posted on regarding the 2019 Kenya census. So I want just to see whether we can find that. Yeah, Kenya census. So this data on Kenya census. Let's pick the top 10 households. So let me copy those three. Copy. Come over. Oh, sorry, it should be on cloud. Let's put the data sets once more here. So let's run that on gender and households. So let me see. Like this. So let's start with this gender. See how it looks. So we have county, male, female, intersex, and the total. So these are the people according to gender, according to the 2019 Kenya census. Now, you would like to work with this data, but you can see here the very first column contains the total count. This total that contains the total males, the total females, the total intersex, and the total population of people in Kenya. So this was about 47 million. So maybe you want to work with the counties, but this is the total for the whole country. So you wanting to work with this data, you'd have to remove this column that has the total. This not column, but this row that has these totals, so that it does not impede your visualization or any analysis that you want to do. And that's where filtering comes in. So let's try to remove this total. Okay, let's go here and say we want that gender data set. Pick that, and then want to filter. And this time, want to filter out. So put the exclamation is equals to. Let's put that in quotation marks, and it is total. Oh, sorry. I need to put the. Sorry. It is under the county. It is under the county column. So under that county column, we want to remove that row called total. And you can see here, it has been removed. So I could say counties. This is counties only without the total. So let's say counties. So we have removed that total row that would have been a problem when you want to do any analysis. Now, let's say, for example, as I was saying, we want the cities. Let's say we want a data set called cities in Kenya. So we take the gender, and then let's filter county. We say when you want to select multiple, use this. Then you concatenate, put it in C. Then you have Mombasa. Sorry. Comma, Nairobi. So let's go to cities. So there is something that I've not written correctly. Nairobi. Nairobi inaandikwa aje? I don't know. Let's look at our data set. It looks like it was on gender.
Nairobi kuna I.
Oh, it's umeandika Nairobi City. Yeah. Nairobi City. Okay. Let's see cities. Yeah. And I think Kisumu is also a city. Kisumu. And if you look here, you can see that it updates how many observations you have. So these observations are rows, and these are columns, how many variables. So Nakuru recently became a city. Put it Nakuru. So for observations, so let's click there. That's what you have. So you have Mombasa, Nakuru, Kisumu, Nairobi City. All right.
I know she'll stick to that. I don't know is the last time.
I only say that because I don't feeling like that.
Somebody's...
Oh. No, I don't know.
Sorry?
Let me try to meet these people.
Papa,
I don't know how to go about that. Oh, goodness.
3 nights.
That's nice.
Kesho tunaenda swimming at least ionje. Imagine that very long time. It's been
Very
forever.
weird people. You'll have to come back.
Yeah, I'm feeling nice. Kai akipole. Nime-unmute kitu and
weird people. Anyway, let's go. So we have filtered this this part. Okay, now let's try something else. I don't want to keep you so much, but let's try something else. So we have selected this. So let's put this down here. Let's do something else. Let's add select. Let's remove in this data set called cities. Let us remove this total column. Total. Let us remove total. It is total. So let's cities. The total column is not. So you have the county, the male, the female, and the tasks. I've removed that because I want us to work that ourselves. So let's go to another function, the last one for the night, called mutate. Now, this mutate function helps create or transform what you're calling a column or a variable. So we have removed this column or variable called total, and we want us to calculate it ourselves. So what mutate does will create for us this total column using normal mathematical formulas. And this is how we'll do it. So let us take this data set. Let's just take it here and copy it here down here. I want to mutate. So what we have done, we took the gender, we filtered in only these cities in Kenya, and then we removed the total column, the variable. And now we want to calculate it. So it's saying mutate. So let's call it total. That the name of that column, we won't call it total. And that total will be equal to, because this is a mathematical formula, we don't use 2 is equal signs. We just use the mathematical formula of 2 is equal. So, and this is equals to male plus female plus intersex. Just put them as they are. So male just as females, adding those columns, plus intersex. Then you run that. Let's go to cities. Here it is our column that we have created called totals. So mutate for now is used to create another column. We can do mutate once more. Let me just put mutate, and let's get a ratio of females to males. Called ratio is equals to males over females over female. So over. Then run that. So let's go to our cities once more. Let's see how it looks like. So we have a ratio. So Mombasa, the ratio of males to females. So this means that Mombasa males are more than females. Kind of weird. In Nakuru, at least females are more. But the ratio is almost 1-to-1. So it's okay. So, but we see there's a difference in Mombasa. There are more females. And we can, if you see, this is 61,000 males. No, this is male to females. Yes, there are more males. Yes, there are more males, sure, and females, and 59. When it comes to Kisumu, 56 males and 59 females. So females are more. Nairobi City, 219 males, 220 females. So females are more in Nairobi. Nakuru, we have 107 males, 108,000. So yes, so we have created this ratio. So that is a function of mutate. That's what mutate does. So we have done 3 functions: select, that helps us select the columns that you want, or deselect those columns; filtering the rows that you need. We did that, and also filtering out, and also filtering multiple, using things that saying at everything that is in here, saying everything in here. And then we have done mutate. Here is mutate. Mutate, we have created a total of males, females, and the intersex, and we have also created a ratio of males to females. And that is what I would wish to cover for today. Next time, among other functions, you're going to work a function called summarize. And then with this summarize function, it will be done with a dplyr package. So, any question before we close it for the night? Silence means no question. Let me see who is present.
Hey, Dan.
Yes, how are you?
Apoleni, I was so late. Apoleni, because I got a call after the break.
Yes.
But now I wanted to know, like, are the first sessions recorded? Because
yes,
when it's a little bit late. So maybe to follow Neza Shana, maybe the first minutes that I go through them.
I will for sure.
Oh, thank you. Good job, Rusty. Bye.
Right. Bye. So anybody else? Said. Said seems to be okay.
When filtering.
Yes.
Done.
Yes.
Yeah, when filtering many, do we have a shortcut for this one? Of like in the case of county, filter county, we have Mombasa, Nairobi, Kisumu. A shortcut for just after the county. This
a shortcut for saying county for these counties, for this for selecting this.
Yes, this one here, right after the word county. We have a shortcut for that, or we just need to key in, like
you have to explicitly key in. You have to explicitly key in. However, there are some helpers that we can use, but that is more advanced. We'll do it later.
Yeah.
You can say maybe we can say maybe any row that contains maybe a certain letter. We can say maybe that contains M. We want that. Maybe that contains N. It depends on the criteria that you want to subset your data. But there is no shortcut, but there are other helper functions to do that. But you have to do